Good morning everyone, I am Gopalakrishnan from 3rd BCC. Now I am going to explain a project predicting cataract eye disease using machine learning. In our project, we are going to predicting the cataract eye disease using machine learning. The goal of this predicting cataract eye disease using machine learning is to use machine learning methods to forecast an individual risk of developing cataracts based on a variety of data inputs. There are normal and cataract eye disease. The above picture shows the difference between normal eye and the cataract eye. There are the existing and proposed system. Existing system, there are the methods, traditional diagnostic methods, automated detection with traditional image processing, existing machine learning solutions. There are 3 methods. Next one is proposed system. The system aims to leverage more advanced machine learning and deep learning techniques to improve accuracy, scalability, and generalization for cataract detection. Deep learning models, we are using CNN model, convolutional neural networks. CNN based with the proposed automated based system will be proposed. Hybrid approaches for multimodal media, AI powered mobile or web application, explainable AI, early detection and predicting modeling, real time integration, cloud based development. We are using this type of model in this predicting cataract eye disease. Next one is software requirement. Programming language, we are using Python, R or MATLAB for developing and implementing machine learning algorithms. We are using the libraries is known as TensorFlow, Keras, Skitlearn or PyTorch for building the training machine learning models. Image pre-processing libraries, we are using OpenCV or Pillow. Data analysis and visualization tools, Pandas, NumPy, Matplotlib or Seaborn for data manipulation, analysis and visualization. We are using management known as MySQL, PostgreSQL or MongoDB for storing managing large datasets. Deep learning for frameworks, TensorFlow, Keras or PyTorch for building and training deep learning models. Cloud computing platforms, AWS, Cloud or Microsoft Azure for scalable computing. These are the literature for review. These are the review of literature. Next one is definition of the problem and scope of the research work. These are the problem statement. For we have to research work. In the scope of the research work, there are the data collection. Objective is to collect and organize a data set suitable for cataract. We are organizing the data set for the cataract eye disease. Data set types, image based type, tableau data, Kaggle, public medical repositories, self captured data. These are the data set types we have used to collecting the data. Data pre-processing, we are researching the images, normalization, data augmentation, splitting data sets. Model selection, we are using basic CNN architecture, pre-trained models. For tableau data, we are using classical machine learning models like logistic regression, random forest, support vector machines. Next one is model training. We are training the model as divide the data to training and testing data. 80% training and 20% data. We have to train the model. Using machine learning or deep learning model. Hyperparameter data, timing, model evaluation. The model is trained. Once the model is trained, using the data set, we can measure performance using metrics such as accuracy, precision, recall, and F1 score. Deployment, monitoring, maintenance, model retraining. It is used to monitoring and maintaining the product. arch detector design. The design is the full form of the application. We have to launch the application. We have to open the front camera, detect face and eyes. We have to detect the face as closed. We have to cut the two eyes in layouts of the camera. We have two layouts, one for left eye and another one for right eye. Next we have to crop the two pupils. We have to crop the two eyes. Next the people color match existing data people's color like. Uh, uh, it will train the cataract eye, cataract eye or normal eye. If it is cataract eye, it will goes to left. If it is normal eye, it will goes to right. It shows the cataract or normal eye. Next one is result and discussion. Data splitting. Train path. First you have train path. Normal images you have 246. Cataract images it is about 245. Total images are 491. If it next test path, we have 60 number of normal images and 61 of cataract eye images. The images shows the we have taken the photo for cataract. For predicting, choose the normal eye or cataract eye. These are the CNN model architecture. We are using convolutional layer, max pooling 2D layer, batch normalization, dropout layer, dense layers. These are the neural network training by pre-process. Training process. The model will output the loss and accuracy for both training and validation. Performance of training versus validation. The final results. Model training metrics: loss, accuracy, val loss, val accuracy. Training and validation loss over epoch. It gradually decreases the model learns to minimize the error. Next one is training and validation accuracy over epoch. The curve showed the above figure shows the curve should ideally rise as the model learns to fit the training data. KNN classification report. These are the methods used to predicting cataract eye. Now we came to conclusion and future enhancement. This is the future scope of the research on cataract detection using machine learning. Class platform integration and cloud-based solutions. Cloud deployment, integration with electronic health records. These are the references of this project. Next one is plagiarism. Source code. First of all, we have to import dataset OS, pandas spd, numpy as np, and the matplotlib, pyplot as plt. From path, we have to import the images from Google Drive for the content with the content as drive. We have to train the path as my data and test path as my data direct test. We have to train path as plant types normal cataract. If it is normal, we have to use the plant types for the coding. Next of all, you have to create a empty list for each plant type, cataract or normal. For both, we are creating both for if it is normal or cataract. We have to calculate the number of files for each plant type. Next, we have to get number of files in plant type folder. File list, we are using file list os.list direct. Next of all, we have to add each file to the corresponding list using plant type cataract.extend file. Elif plant type normal. If it is cataract, we are using cataract.extend. If it is normal, we are using normal.extend. Next, print number of files. We have to print the number of images for finding the normal or abnormal. Next, we are using total number of files, total number of images and length. Next, test path. Using test path for normal or cataract. We are using plant as types. Create empty list. We have to create an empty list for each plant type. If it is cataract, we have to use such files for cataract. If it is normal, we have to use normal for normal files. Next, we have to get number of files in plant type folder. If it is folder, we have to get the number of folders. Next of all, we are using corresponding list for each file. Printing the number of files. Next one, we have to update total number of files. Print total number of files. Printing all the files and folders and images for getting the normal or abnormal. We are using x and y for normal shape mean. We are using x for normal, y for abnormal. Cataract mean shape x, and we are using x and y for cataract mean shape. We have to generate the image data. For that, we are using TensorFlow and Keras preprocessing. Image data generation, rotation image. We have to use all the images as TensorFlow. Next, we are creating a model yearly shopping. We are using here also the TensorFlow for importing yearly shopping. We are giving the target size, color node, RGB, batch size. For creating the data. We have to import all the model. We have used filters, kernel size activation, and model max polling to be batch normalization, dropout, max polling, flatten, denser. We have to import all the model with the file. Then we are using the PLT figure plot. We are using all the labels. Finally, we have to save the model. We have to save the model as TensorFlow. Predicting on an image, we have to predict the image with the TensorFlow. Then we have to load the model. We have to open the image and convert it into a suitable format. Finally, we have to make a guess and print the predictor class on the screen. After printing, the output will be here.